In this last video, we'll be looking at something that we actually cannot even do with arithmetic series, but that we can do with geometric series, and that is finding the sum of an infinite geometric series. In other words, adding up all of the terms in the series that goes on forever, not just adding up the first n terms. Now, this is only sometimes possible with geometric series and sometimes not. Specifically, a geometric series is said to converge if we can find this sum, right? If that sum approaches a single number. Now, this will happen when the size of our common ratio, or R, is less than 1. What that really ends up meaning is when the size of the numbers in the series is getting smaller and smaller. So this would be for if your common ratio is something like 0.7 or -3/4, those would both work. On the other hand, a geometric series is said to diverge if we cannot find this sum. Now, this occurs when the size of the common ratio is greater than 1. Or, a quick way to see by looking at it, when the numbers in the series, the size of the numbers is getting bigger and bigger. So examples that would work for this common ratio would be like 2 or -1.5 or -30. Those would all mean that it diverged. The formula for finding this sum is actually easier than the one for a partial sum. It's just a sub 1 divided by 1 minus r. So let's try to apply that in a couple cases. In this first one, we have to first determine, does it actually converge or not? And then if it does converge, we can find the sum. So first, that means we have to find r. Well, we can find r by doing a sub 2 divided by a sub 1, which is just 4 divided by 5. Well, 4 divided by 5, the size of that, or the absolute value of it, is indeed less than 1. So that means that this converges. Which means that we can now apply our formula and find the sum of this entire list of numbers as it goes on forever. It will just be a sub 1, which is 5, over 1 minus r, which is 1 minus 4/5. Well, 1 minus 4/5 is 1/5, so this is 5 over 1/5. And then this is the same as 5 times, we can multiply by the reciprocal of this fraction, which is 5 over 1, which gives us that the sum is 25. Let's look at one last example. In this case, to get from 2 to -4, we're still looking for r, we're going to have to do times -2. Or if you aren't sure of that, you can always check it by doing a2 divided by a1, which will give us -2. Well, the absolute value of -2 is 2, which is greater than 1. So that means that this is going to diverge. And if it diverges, we cannot find the sum, so the problem is over.